At first glance, the relationship between the electrical and the chemical engineer seems remote. Few applications of electrical technology in a chemical industry are control system in chemical plant, computer numerical control and automation in chemical plant, and electrochemical engineering. Electrochemical engineering, a specialization of chemical engineering, deals with electrochemical processes. This includes batteries, fuel cells, electroplating, electrochemical machining, and electrochemical process for production of chlorine, sodium hydroxide, hydrogen, alkali metals and fluorine. Chemical engineers regularly encounters electronic devices in process control. Originally, control of continuous processes was all done using analog instrumentation. Now it is mostly done by computers pretending to be analog instruments. Process control engineers, a chemical engineering specialty, used to have to tune the analog controllers to get proper control of the processes. What is process control? Process control is an automated system that takes a look at what is going on in your process and makes adjustments based on those observations to keep everything on track. The aspects of the system your process control looks at are called parameters, while the outputs that get changed as a result of those observations are called controlled variables. Process control uses measurements of a process's parameters to make changes to its controlled variables. Set point is the number that represents the target output or operating state you want a process to achieve. Process control is everywhere because of its broad uses. It's a major consideration in chemical, electrical, industrial and mechanical engineering, just to name a few. Main kind of process control to consider is the feedback control system. To see this in action, let's revisit heat exchanger. In a shell and tub heat exchanger, you run one fluid through a series of pipes to exchange heat through pipes, with the surrounding fluid. Let's say you are using steam in the pipes to raise the temperature of oil to 200 degrees Celsius before it flows into an engine. At the input end of the steam, there is an inlet valve that controls how much steam is entering the exchanger. The goal is to make sure the oil leaves the heat exchanger at a given temperature, 200 degrees Celsius. That's the set point. In the feedback control, sensor is placed to measure temperature at output end for fluid. Sensor continuously feed temperature data to the controller. Difference between observed temperature of output and set point is called error. Application of chemical engineer principles to problems of electrical manufacturing has helped to supplement the specialized knowledge of electrical engineer. Working together, the electrical chemical engineering team has produced improvement in operating performance.